Hi, my name is Faith Jean, and I'll be introducing Physics 2212 Lab 2, Lines of Charge. The purpose of this lab is to create charges between two insulated objects, which would be tape, determine the excess amount of charge on one piece of tape, and recreate the interaction in GLOW script. The preliminary results show that the tapes repel each other because they have the same charge, and the tapes are positively charged. The charge on the tape was 3.88214 times 10 to the negative 8 coulombs, and the magnitude of the excess charge was 2.4634 times 10 to the 11th electrons. Key concepts in this lab include the gravitational force, which is the force that attracts any two objects with mass; Newton's second law, which is a force that applied to an object that rests causes it to accelerate in the direction of the force; Coulomb's law, or the electric force, which is the force between two stationary electrically charged objects. The electric force formula is on the left, but we'll also be using the E field formula for a rod, which is on the right. And Coulomb's constant is 1/4 pi epsilon naught, which is 9 times 10 raised to the 9th newtons times meter squared over coulomb squared. And the magnitude of the electric force does not consider the unit vector and takes the absolute value of the charge. Key assumptions you can make in this lab is that the charge is evenly distributed across the tape, a resistance is ignored, and both tapes have the same amount of charge. The procedure for this experiment is to 1. Create U-tapes by placing one tape on a table and taping the other on top, and you would repeat this another time. You pull off the U-tape from the base tape, and then you observe the interactions between the two U-tapes. Then you would observe the interactions between the U-tape and a charged plastic object. We used a pen. Then finally, you would suspend one tape on an object of equal height and then place the other U-tape below the suspended U-tape and observe the interactions, and you would also record the distance between the tapes. The observations observed between the interactions between the U-tape and the hand was an attraction. Between the U-tape 1 and U-tape 2 was a repulsion, and the U-tape and the negatively charged pen was an attraction. Therefore, we can conclude that the tapes are positively charged. On the slide is the data/calculations for this experiment. The length of the tape was 0.2 meters, the width of the tape was 0.02 meters, and the mass of the tape was 0.0002 kilograms, and the distance between the tapes was 0.05 meters. The charge on the tape, as calculated in GLOW script, was 3.88214 times 10 to the negative 8 coulombs, and you solve for this by setting the force of gravity equal to the electric field of the rod, and is set it equal to solve for Q. And the number of electrons on the charged tape was 2.4634 times 10 to the 11th, although found in GLOW script. Some possible sources of error can include rounding and inaccurate distance, length, and width recorded. On the slide is the code used to generate the computational model, which includes the physical constants, the calculations used from the tape, such as the mass, and then a loop to create the electric field function, as well as the functions to create the top and bottom tapes within the experiment. And on this slide is the loop to create the electric force on the top tape due to the bottom tape. So what if we had modeled the tape as a point charge rather than distributed? Well, from lab 1, when we calculated as a point charge, the magnitude was 2.3354 times 10 to the negative 8, and now it is 3.88214 times 10 to the negative 8. So the line charge model has a greater charge than the point charge model. So why do these estimates differ, and which one is closer to the real value? The charge being distributed rather than concentrated at one point causes the difference, because the distributed charge takes into account the rod length and the distance from the observation location, and this model would be more accurate because tape is more similar to a rod shape. Thank you for your time.